humanity's greatest discovery will be knowing that we are not alone. This phrase, spoken by the character Roy McBride, played by Brad Pitt in the film Ad Astra, 2019, reminds us of a disturbing truth. The universe is vast, mysterious, and full of possibilities. With billions of galaxies and trillions of planets, it seems inevitable that alien life exists. But, to this day, we have found no sign of it. Why? Today, we'll explore the possible answers to this conundrum, from scientific explanations to logic-defying theories. Because, at the end of the day, the question remains, are we really alone? The universe is vast. So vast that, even with all our technology and knowledge, we have barely scratched the surface of its immensity. Billions of galaxies, each with billions of stars, and around those stars, trillions of planets. The math is clear. The probability that life exists somewhere else is overwhelmingly high. And yet, here we are, alone. No sign, no message, no evidence that we are not the only inhabitants of the cosmos. This contradiction between the high probability of alien life and the complete absence of evidence is what we call the Fermi Paradox. It is named after physicist Enrico Fermi, who, in a casual conversation with colleagues in the 1950s, asked, "Where is everyone?" It was a simple question, but one that still resonates today as one of the greatest mysteries in science. Because, if life is so likely, why have we never encountered aliens? Are we looking in the wrong place? Are they hiding? Or is the answer much more disturbing? That we are, in fact, alone in the universe. To understand the Fermi Paradox, we must first consider what we know about life. On Earth, life emerged about 3.8 billion years ago, under conditions that, at first glance, appear hostile. And yet, here we are. This suggests that life can arise in a wide variety of conditions, given the right ingredients: water, energy, and organic molecules. And given that these ingredients are common in the universe, logic suggests that life should be abundant. But life alone is not enough to resolve the paradox, because even if life is common, the question is, where are the advanced civilizations? Civilizations that, like ours, developed technology, built cities, and eventually looked to the stars. Civilizations that could send signals, explore space, or even visit us. And this is where the Fermi Paradox becomes even more intriguing. Because if intelligent life is as likely as simple life, we should be surrounded by evidence. We should be receiving radio signals, detecting alien megaconstructions, or, at the very least, finding traces of their existence. But so far, we haven't found anything. So, what's going on? There are several possible explanations for the Fermi Paradox, and none of them are completely satisfactory. Some are optimistic, some are dark, and some are just plain weird. One of the simplest explanations is that we are looking in the wrong place. The universe is vast, and our ability to explore it is limited. So far, we have only been able to send probes to the planets in our solar system and detect radio signals in a small fraction of the galaxy. It's possible that aliens are out there, but in places we can't yet reach. Another possibility is that the aliens are hiding. Maybe they've decided it's not worth contacting us, or maybe they're watching us from afar, like scientists watching animals in a natural habitat. This idea, known as the zoo hypothesis, suggests that we are like animals in a cosmic zoo, being watched by more advanced civilizations, who have decided not to interfere. But there are also darker explanations. One is the idea that intelligent life is incredibly rare. Perhaps the evolution of intelligent beings is such an unlikely event that, even in such a vast universe, we are the only ones. Or perhaps intelligent life has a tendency to self-destruct. Nuclear wars, climate change, pandemics. There are countless ways a civilization can end before it gets a chance to explore the cosmos. And then there's the possibility that aliens are trying to communicate, but in ways we can't understand. Perhaps they use technologies that are beyond our understanding, or perhaps their messages are hidden in phenomena that we do not yet know how to interpret. After all, just a few decades ago, we didn't know that radio pulses from space were caused by pulsars, rapidly spinning neutron stars. Who knows what else we're getting wrong? But perhaps the most disturbing explanation of all is that we are, in fact, alone. That, in such a vast universe, intelligent life emerged only once. Here, on Earth, this idea is difficult to accept because it puts us in a unique and lonely position. But at the same time, it reminds us how precious life is and how important it is to protect it. The Fermi Paradox is not just a scientific question, it is an existential question. It forces us to confront our own insignificance in the cosmos and question what it means to be human. Because at the end of the day, the question is not just where is everyone, but also who are we, and what is our place in the universe. These are the questions we will explore throughout this video, because as much of a mystery as the Fermi Paradox is, it's also an opportunity, a chance to look up at the stars and ask ourselves, what's out there? The idea that we may not be alone in the universe is not new. Since the dawn of humanity, we have looked up at the starry sky and asked ourselves, what is out there? Are there other worlds, other forms of life, other civilizations? These questions are not just scientific, they are deeply human, rooted in our curiosity and our desire to understand our place in the cosmos. In ancient times, many cultures believed that heaven was inhabited by gods, spirits, or supernatural beings. For the ancient Egyptians, the stars were the homes of the gods. In Greek mythology, the cosmos was governed by deities who directly influenced life on Earth. And in ancient China, celestial events such as eclipses and comets were believed to be messages from the heavens. But as science began to advance, these ideas began to change. In the 4th century BC, the Greek philosopher Epicurus proposed that the universe was infinite and that there were other worlds besides ours. This idea was revived centuries later, during the Renaissance, when scientists like Giordano Bruno suggested that stars were distant suns, each with their own planets, and, possibly, their own life forms. These ideas were revolutionary, but also dangerous. Bruno, for example, was condemned by the Inquisition and burned at the stake for his beliefs. In the 17th century, with the invention of the telescope, we began to explore the cosmos in a more systematic way. Astronomers such as Galileo Galilei and Johannes Kepler observed that the planets in our solar system were physical worlds, not just points of light in the sky. This opened the door to the idea that these worlds could harbor life. Kepler, for example, speculated that the Moon and Mars could be inhabited, but it was in the 20th century that the search for alien life really gained momentum. In 1960, astronomer Frank Drake conducted the first search for extraterrestrial intelligence. SETI experiment, using a radio telescope to look for radio signals coming from other stars. Although the experiment found nothing, it marked the beginning of a new era in the exploration of the cosmos. An era in which science began to approach the question of alien life in a systematic and rigorous way. And then, in 1950, came the question that changed everything. Where is everyone? During a casual lunch with colleagues, physicist Enrico Fermi raised this seemingly simple but deeply disturbing question. If the universe is so vast, and life is so likely, why haven't we found any evidence of aliens? That question, which became known as the Fermi Paradox, cast a shadow over the search for extraterrestrial life, a shadow that persists to this day. Since then, scientists have proposed numerous explanations for the Fermi Paradox. Some are optimistic, suggesting that we haven't looked hard enough, or that aliens are hiding. Others are darker, suggesting that intelligent life is incredibly rare, or that civilizations tend to self-destruct before reaching the stage of interstellar exploration. But at the same time, science has made extraordinary advances in the search for alien life. In 1995, astronomers discovered the first exoplanet, a planet outside our solar system. Since then, we have identified thousands of exoplanets, many of them in habitable zones, where conditions may be suitable for life. Additionally, missions like the James Webb Space Telescope are helping us study the atmospheres of these planets, looking for signs of life, such as oxygen, methane, and water. And then there's the issue of biosignatures, chemical or physical signs that indicate the presence of life. In 2020, scientists announced the detection of phosphine in the atmosphere of Venus, a gas that, on Earth, is produced by microorganisms. Although the discovery is still controversial, it raised the possibility that life could exist in unexpected places, such as the acidic clouds of Venus. But, no matter how much science has advanced, the Fermi Paradox remains unanswered, because even with all our technology, we still haven't found any evidence of alien life. No radio signals, no spaceships, no cosmic mega-constructions. Just silence. This silence is disturbing, but also fascinating. It forces us to confront our own limitations and question what it means to be human. Because at the end of the day, the search for alien life isn't just about what's out there. It's about who we are and what our place is in the universe. And this leads us to a fundamental question. Are we ready for humanity's greatest discovery? Are we ready to know that we are not alone? Or, perhaps, that we are? If there is something that defines humanity, it is our ability to dream and seek answers to the most difficult questions. And when it comes to the Fermi Paradox, this search has led us to extraordinary advances. Advances that are bringing us, little by little, closer to an answer to the question, where is everyone? One of the greatest successes in this search is the SETI, Search for Extraterrestrial Intelligence Program, which for decades has used radio telescopes to search for radio signals coming from other civilizations. Although we haven't found anything yet, SETI has taught us a lot about looking for alien life. He showed us that the universe is incredibly silent, or, at least, that we are listening on the wrong frequency. And, most importantly, he gave us the tools to keep looking. But SETI is just the beginning. In recent years, the search for alien life has gained new momentum with the discovery of exoplanets, planets outside our solar system. Since 1995, when the first exoplanet was discovered, we have identified more than 5,000 such worlds, many of them in habitable zones, where conditions may be suitable for life. This discovery was a game changer because it showed us that habitable planets are not rare. They are common. And if they are common, life can be too. One of the most ambitious projects in this area is the James Webb Space Telescope, launched in 2021. With its ability to observe the universe at infrared wavelengths, the James Webb is helping us study the atmospheres of exoplanets in unprecedented detail. It can detect signs of water, methane, carbon dioxide, and other gases that could indicate the presence of life. In other words, it's helping us look for biosignatures, chemical signals that can only be produced by living organisms. And then there are the space missions. In recent years, we have sent probes to explore Mars, Europa, one of Jupiter's moons, and Enceladus, one of Saturn's moons, places that, although inhospitable, may harbor simple life forms. On Mars, for example, the Perseverance rover is collecting soil samples and looking for signs of past life. And, on Enceladus, the Cassini probe detected plumes of water rising from its surface, suggesting the presence of an underground ocean that may be habitable. But perhaps the most impressive advance is the idea of searching for technosignatures, signs of alien technology. This includes everything from radio signals to cosmic mega-constructions, like the hypothetical Dyson sphere, a gigantic structure that an advanced civilization could build around a star to capture its energy. while we haven't yet found any technosignatures. The search for them is helping us expand our understanding of what's possible in the universe. And we cannot forget private initiatives. Companies like Elon Musk's SpaceX and Jeff Bezos' Blue Origin are making space exploration more accessible and opening up new possibilities for the search for alien life. SpaceX, for example, plans to send humans to Mars in the next decade, which could help us answer the question, is there life on the red planet? But as impressive as these advances are, they also raise important questions. Because, at the end of the day, the search for alien life is not just a scientific question, it is also a philosophical and ethical question. What will we do if we encounter aliens? How will we communicate with them? And, perhaps most importantly, how will it change our view of ourselves? These are questions that we still don't have answers to, but at the same time, they're a reminder that the search for alien life isn't just about what's out there. It's about who we are and what it means to be human. Because ultimately, humanity's greatest discovery won't be knowing we're not alone. It'll be understanding what that means. Behind all the excitement and advances in the search for alien life, there is a dark side. A side that rarely makes headlines, but is as real as the discoveries we celebrate. Because while science brings us closer to answers, it also forces us to confront our own mistakes, limitations, and fears. One of the biggest problems in the search for alien life is the lack of scientific consensus. While most scientists agree that alien life is possible and even likely, there is heated debate over how to look for it. Some advocate searching for radio signals, while others believe we should focus on biosignatures or technosignatures. This lack of consensus not only makes it difficult to coordinate efforts, but also creates divisions within the scientific community, delaying progress. And then there is the problem of scientific fraud and exaggeration. Throughout history, there have been numerous cases where seemingly revolutionary discoveries turned out to be false. In 1996, for example, NASA scientists announced the discovery of possible microorganism fossils in a Martian meteorite. The news was met with enthusiasm, but years later most experts concluded that the evidence was inconclusive. Although it was not intentional fraud, the case highlighted the dangers of jumping to conclusions in such a complex field. Another example is the detection of radio signals that were initially interpreted as possible alien messages. In 2015, astronomers detected a signal coming from a star called HD 164595, which appeared to be artificial. However, further investigation revealed that the signal was likely caused by terrestrial interference. These cases not only generate disappointment, but also fuel public skepticism, making it difficult to gain support for future research. But perhaps the biggest challenge of all is the ethical issue. Because as much as we want to encounter aliens, we need to ask ourselves, are we ready for it? In 2010, physicist Stephen Hawking warned that trying to contact extraterrestrial civilizations could be dangerous. He compared a possible encounter with aliens to the encounter between Europeans and the indigenous people of the Americas, an encounter that, as we know, had devastating consequences for the indigenous people. According to Hawking, an advanced civilization could see us as nothing more than resources to be exploited. And then there's the question of how we would react to a discovery. In 1960, NASA commissioned a report called the Brookings Report that explored the social implications of finding alien life. The report concluded that such a discovery could cause panic, destabilize religions, and even collapse social structures. While these predictions may seem far-fetched, they raise an important question. How would humanity deal with the news that we are not alone? But the problems don't stop there. There is also the risk of biological contamination. If we find life on Mars, Europa, or elsewhere, how will we ensure we don't contaminate it with microorganisms from Earth? And conversely, how do we ensure that we don't bring back something that could be dangerous to life on Earth? These are dilemmas that scientists are only beginning to address, but which will have profound implications for the future of space exploration. And then there is the issue of inequality in access to space exploration. While the search for alien life is a global effort, the reality is that only a handful of countries and private companies have the resources to participate in it. This raises questions about who will have the right to make discoveries, and how these discoveries will be shared with the rest of the world. Are we creating a future in which only the richest and most powerful will have access to humanity's greatest discoveries? But perhaps the most disturbing aspect of it all is the silence. Because no matter how much we search, the universe remains silent. No sign, no message, no evidence that we are not alone. This silence is what astrophysicist Paul Davies called the Great Silence. A silence that for some is more frightening than any answer we could find. This silence raises a dark possibility. What if the Fermi Paradox is not a paradox, but a reality? What if we are alone in the universe? This idea is difficult to accept because it puts us in a unique and lonely position. But at the same time, it reminds us how precious life is and how important it is to protect it. Ultimately, the search for alien life isn't just about what's out there. It's about who we are and how we choose to deal with the challenges we face. Because, as vast and mysterious as the universe is, the greatest mystery of all is still ourselves. Humanity's greatest discovery will be knowing that we are not alone. This phrase, spoken by the character Roy McBride in Ad Astra, encapsulates what is at stake in the search for alien life. But what if this discovery never happens? What if the silence of the universe is eternal? What does this mean for us, for our view of ourselves, and our place in the cosmos? The Fermi Paradox is not just a scientific question. It is a deeply existential question. It forces us to confront the possibility that we are unique, that intelligent life is such a rare event, that in a universe of trillions of stars, it has emerged only once, here, on Earth. This idea is both frightening and inspiring, because if we are truly unique, that means that the responsibility for protecting and preserving life falls entirely on us. But at the same time, the Fermi Paradox also reminds us that the universe is vast and full of possibilities. He challenges us to keep exploring, to keep asking, to keep dreaming, because at the end of the day, the search for alien life isn't just about what's out there. It's about who we are and what it means to be human. Consider the impact the discovery of alien life would have on humanity. It would change everything. Our science, our philosophy, our religions, our view of ourselves. It would force us to rethink our history, our future, and our place in the cosmos. But at the same time, it would also bring us together. Because, in a universe where we are not alone, the divisions between nations, cultures, and beliefs would become insignificant. We would finally be a single species, sharing a single planet, in a vast ocean of stars. But what if we never find alien life? What if the silence of the universe is eternal? This possibility, although disturbing, also has something to teach us. She reminds us that life is incredibly rare and precious. She challenges us to value what we have, to protect our planet, and to care for each other. Because if we are alone, that means we are the guardians of something unique, something that doesn't exist anywhere else in the cosmos ultimately. The Fermi Paradox isn't just a question about aliens, it's a question about us. It forces us to confront our own limitations, our own fears, and our own hopes. He reminds us that as vast and mysterious as the universe is, the greatest mystery of all is still ourselves. And perhaps that is the true lesson of the Fermi Paradox, that while we look to the stars for answers, we also need to look within, because, ultimately, humanity's greatest discovery won't be knowing we're not alone. It'll be understanding what it means to be here, now, on this little blue dot, floating in the vast ocean of the cosmos.